Hello friends, today in this video uh, I will show how to remote sites. For example, I have taken here is a bank branch at site A and its bank headquarter at site B. So these two remote networks, through the use of ISP, I will try to connect the site-to-site VPN connectivity. So for that, the first network for the bank branch inside A, I've taken the network as 192.168.1.0/24, in which I have given the this site A computer as 1.10 IP, and its headquarter at site B is having the network of 192.168.2.0/24, and its uh, remote computer is given as 192.168.2.10, and the customer routers at the respective location are connected to their ISP, which is internet service provider. So in normal scenario, what happen when from this side A, when he will ping data or send packet to its headquarter, the ISP will know uh, from which IP the data is being sent, uh, and to at what destination it is sending, and also it can see also the what other traffic content. If some intruders, which if they connected to the ISP, uh, they can check the data, and when they can also modify. So for that purpose we are using VPN. So in VPN, what happened whenever I send packets from here to this headquarter, the ISP will not have any clue that the data, that from which location data is being sent, and to what destination it is being sent. So first we will try to configure a normal network without VPN, and we will see the flow of traffic. So already I have configured the IP address to the respective computers and routers. So for the network connectivity between the three routers, I will use RIP protocol. So let's move to router number 1. So router number 1, so in the CLI mode, enable config T. So RIP protocol, and what are the networks that I'm going to define. So in the, again, bringing the this main screen, So in my router 1 I have two networks. First is 10.0.0, this one, and another is 192.168.1.0. So I have to advertise this network. So once again to router number 1. So network 192.168.1.0. This is my private, we can say private network, this one, and the network another is the 10.0.0.0. This is my 10.0.0.0. This is my WAN side network. Now that's it. So similarly we will advertise for router number 0, in which the network I have to advertise are 10.0.0.0 and the 20.0.0.0. So router number 0. Enable 50 router rib network 10.0.0.0 and the network 20.0.0.0. Okay. Now for the third network, this is router 2. Again it will have two network. One is this one 20.0.0 and another is 192.168.2.0. So again advertise this one. So router number 2. So CLI enable config zip network 20.0.0.0 and 192.168.2.0. That's it. Now as I have enabled the dynamic routing protocol in all the networks, now we can see the packet flow when I send packet from PC0 to PC1. So let's move to PC0. So yeah, so ping 192.168.2.10, which is my remote site uh, computer, or you can say the headquarter computer PC. Is pinging, and and we want to see how the packet flows from the source to the destination. For that we will see the trace route 92.168.2.10. So here it says the packet start from 192.168.1.1, which is nothing but the gateway of the our source computer, then it will go to the 10.0.0.2. So let's move again to the this our main screen. So when I start the packet from PC0 to PC1, first it will move to its gateway. So the gateway is having the IP address of 192.168.1.1. So after this, it will go to the next hop, which is nothing but this ISP, this WAN IP 10.0.0.2. So after this, it will again move to the next hop, which is nothing but the remote headquarter WAN IP 20.0.0.2, and it will finally reach to the destination PC. Let's check again our this. So here, so after the 1.1.1, which is the gateway, moves to the 10.0.0.2, which is nothing but the this next hop or ISP WAN IP. Then it moves to the 20.0.0.2, which is nothing but the WAN IP of the headquarter. Then finally to the destination PC. So here what it is happening when we send packet from here to the destination. ISP knows the details that from which source IP the packet is coming, and to which destination the packet is going, and also the content of the packet. The ISP will know. So we don't want it. We want a secure connectivity between the branch and the headquarter without any knowledge of the ISP. For that, we will configure VPN now. So for it, we will go to the this router 1. Okay. So to connect a VPN connectivity means we are going to make a tunnel between the two remote locations, and the tunnel, and to create tunnel we have to go through two phases. First phase will be the management plan or control plan, and the second phase will be the data plan. So I'm creating an access list. The access list, I still haven't done any video on this or on access list, but in future I will try to make videos on access list also. So in access list we have two type. One is your this standard one, and another is the extended one. So I'm going to use the extended one. Access list 100 permit IP. So I'm going to permit the source IP, which is nothing but 192.168.1.0, and its wildcard mask 0.0.0.255, and my destination IP to which I want to send packet. So it will be the headquarter IP. So 192.168.2.0, it's wildcard 0.0.0.255. See, access list created, and we can also see the access list here. So access list, so detail it will come. So in serial number 10 of the access list 100, it says that it will permit IP originating from this 192.168.1.0, and those packets and which is destined for which network, 192.168.2.0. Only this packets which are with source this and with destination this, they are allowed. So for now, for creating the tunnel, so for the phase one, which is the management plan or control plan, crypto ISECM, which is this is nothing but Internet Security Association Key Management Protocol. So this is required to create the this management plan. So policy number 10. So here I will describe which encryption method I am going to use, and which which authentication method I'm going to use. So first, encryption method, let's say I'm using AES, which is nothing but advanced encryption system, advanced encryption standard. And here we can use 128 bit, or we can also use 256 bit. It is up to us, but for example I'm here using 256 bits, and the authentication is pre-share password. So pre-share, and here Diffie-Hellman group, this is required, means how we are going to share our key actions. So it will describe the key actions priorities. Wait, authentication gr group 5, and now I'm going to define my key, which is nothing but the password. So crypto second key, let's say our password is some xyz, or you can say simply VPN. Password is VPN, and this password is required on which address. As I am sending packet from source to the destination headquarter, so the address should be the headquarter IP, because this key is required only when I'm going to send the traffic to destination. So address should be destination when IP. Again, I am bringing the screen here. Yes, I am sending the packet to the tunnel. So this packet has to be uh, the peer, or you can say the address, the tunnel where the packet has to reach is the WAN IP of this remote one. So the WAN IP is 20.0.0.2. So So this is 20.0.0.2. Okay, here my phase 1 or management plan is finished. Now for the phase 2, which is for the data plan, crypto IPsec is IP security, and I have to define a transform set on the particular block of data which I am going to do tunneling. So let's say its name as VPN remote, say, for example. It is just the name, because the I'm just giving the name to this particular block, so on which we are going to this do the authenticator, do this encryption process, all those things. So encryption security payload, and in this I'm using the AES encryption method and the encryption security payload, and this is my this hashing. This is nothing but security hashing association and hashing message authentication code. So my this here my encryption is AES, and I am going to hash the data so that no one can this figure it out. So no third party can this change my data. So for that, so next is, now I have to create a crypto map. uh, this crypto map I'm given here VPN, name as say bank, name is VPN bank, some identifier 1, and I have to map this two, means between the management plan and the control plan, this management plan and the data plan. For that I've defined this. After this, it is asking this crypto map will remain disabled until a peer and valid access list has been configured. So first, let's just give some description of this particular crypto map. Let's say I'm just giving name as VPN to headquarter. Okay, and as it is asking to set a peer address, so set peer. The peer should be the WAN IP of the headquarter, which is nothing but 20.0.0.2, and the valid access list. So access list is nothing but match. We have defined access list as 100 here. 100. So 100, and the transformation set VPN remote, which we have configured. So we have to enable in this crypto map. So the name of the transformation is VPN remote. We have to be careful while doing this, as it has to be the same as we have defined before. So here my phase 2 or the data plan is finished. Just now we have to apply it to which interface we want. To bring the main screen, So I have created the management plan and the data plan. So now I want to apply it to the WAN interface of the customer router, which is going to be connected to the ISP. So at serial port AC010, I want to apply this configuration. So jet c 0/1/0, the crypto map, and the crypto map we have created was VPN bank. As soon as I have given the this configured in the serial port, now it says that the now this my crypto is now on. So similarly we have to do for at the headquarters side also. So we have done here. Similarly we have to done at the headquarters side also. So let's move to router number 2. Okay, so here also access list 100, permit IP, the this private IP of the headquarter 192.168.2.0, wildcard 0.0.0.255, and destination, which is the branch private IP 192.168.1.0, wildcard 0.0.0.255. Now crypto second same policy term encryption AES, the at the before we have used AES to 56 bit, so same we have to use here also. Authentication pre-share, and the Diffie Hellman group 5 exit, the crypto second key, the key we use that VPN, and the address. Now here we are going to use the VPN key where at the destination. Now as we are sending packet from the headquarter, destination should be the branch. So branch when IP, so branch when IP is 10.0.0.1. Again crypto IP security transform set, here the let's say VPN bank. Okay, and the encryption security payload AES encryption security payload with the hashing one, this, and the crypto map, VPN remote 1 IPsec going to map. So here also I will say description is VPN to branch. Okay, let's see it. Now here we have to enable the peer address and the access list. So set peer is nothing but the WAN IP of the branch 10.0.0.1, and the set transformation set is VPN bank. So VPN bank, and the access list is 100. Now we have to configure in which port, the serial port AC010 of the this headquarter customer router. So interface AC0/1/0, and the crypto map VPN remote. Okay, now I have created the tunnel. This now we can check the trace route again. Before trace route, we will see whether it is pinging or not. So let's move to PC0. This so 192.168.2.10, which is the headquarter IP. It will take some time for the processing of that crypto. So again, now it's pinging. So now let's check the trace route. 192.168.2.10 trace route of this thing. Now it says that it is going to 192.168.1.1, which is the gateway of the branch. Then going to direct 20.0.0.2, which is nothing but the WAN IP of the remote site, which is the headquarter. So 20.0.0.2. So from 1.1 to 20. So let's go to our main screen again. Now packet is going from this to the its gateway, which is nothing but 192.168.1.1. Then it directly goes to the 20.0.0.2, bypassing the ISP. So ISP has no idea that packet is being sent from here to here. So there is a direct tunneling between this router 1 and router 2. And this so after the 20.0.0.2, which is the WAN IP of the headquarter, it directly goes to the our destination PC 192.168.2.10. Similarly, we can check from the headquarter side also. So this is the headquarter PC. What is also ping 192.168.1.10. First it is pinging the branch. Now trace to the branch 192.168.1.10. So this here also it start from the its gateway of the headquarter 192.168.2.1, directly goes to the 10.0.0.1, which is the WAN IP of the branch, and directly to the destination PC 192.168.1.10. So again, let's see here. When I send packets from here, first it will go to its gateway 192.168.2.1, and directly goes to the WAN IP of the branch 10.0.0.1 bypassing the ISP. So in this way we can secure the connection between the two uh, remote location by the use of IPsec VPN. So this is a simple demonstration how this VPN works. So uh, in my next video I will try to make a video on how we access internet in general case, like from our this private IP. To connect to the internet we need public IP, so those network address translation net I will do, and after that net then I will combine this VPN and the net together, so that when this from branch to headquarter, at the same time when traffic is sent from branch to headquarter, it will go by the VPN traffic, and when the branch want to access internet, it will go through the net by changing its private IP to the public IP to access the internet. So uh, thank you friends for watching.